Welcome and thank you for joining again. We'll take a look at question number 17 on page 98 from the textbook. So consider the function f of x equals ax plus b over cx plus d. So we are given the equation of some function in rational form. And there's so many coefficients missing in here, so we're going to write them all and we won't be afraid of them. So let's keep reading the question and read the problem, information given, the connection between whatever you are trying to find and whatever you're given is somewhere, and always have faith in that. So we are given that x has to be different than negative d over c. So why do you think we're given this information? So the reason why is because, as you can see, c and d are in the denominator, and cx plus d equals 0 can produce or can lead us to the restriction, which is at negative d over c. So x is already different than negative d over c, and we are assured about it. Now a, b, c, and d are non-zero constants. So as you can see, these are all constants, and again, the assurance that we are given here, or reassurance, is that they're not zero. So what are the conditions on A, B, C, and D to ensure that each tangent to the graph of the function has a positive slope? So the key information is hiding right here. So the tangent to the graph of f has a positive slope. Each tangent means the tangent drawn at any point x. And we want the slope to be positive. So when we say the slope of a tangent, remember we always mean the derivative of the function. And since the slope of any tangent is positive, that means the derivative at any x has to be positive. So in other words, as you might be thinking right now, we have to find the derivative. So to find the derivative in a rational function, we use the quotient rule. So that means that we are finding the derivative of the numerator, ax plus b, and multiply the numerator by the denominator, cx plus d. And then subtract. That's how the quotient rule works, right? And then subtract the derivative of this line was not that straight, of the denominator, which is derivative of cx plus d, multiplied by the numerator, which is ax plus b. All right, so all this divided by cx plus d to the power of 2. Again, recall that the derivative of, or the quotient rule states that the derivative would be f prime g minus g prime f over g squared. So let's differentiate. And let's ignore the fact that, these missing coefficients are bothering us. Well, they're not. So the derivative of ax plus b, with a being a coefficient of x to the power of 1, would be just a. Now, derivative of b is 0, so the derivative of this entire thing is just a. This will multiply cx plus d. And then we have minus the derivative of cx plus d. Again, similarly, we're going to think that the derivative of cx is simply c. And derivative of d is 0, multiplying ax plus b. And this will be over cx plus d to the power of 2. So let's simplify. Big fraction line, why not? So we'll expand now. So we're going to bring a n and we're going to bring c n. So we have acx plus ad. So list the coefficients in alphabetical order. It's easier that way. Minus acx minus bc. So remember that these will turn with a negative sign here. And divided by cx plus d squared. Check and see if we have simplified completely. So you can tell that here we have like terms. They will add to or subtract to 0, we should say. And the only terms we're left with here are AB and BC. So we'll write AB minus BC. And now I'm really thinking about BC, the beautiful British Columbia, for some reason. All right, so here we go. Here, power of 2. So this is the most simplified form of the derivative. So I'm going to read the question again once I've simplified to refresh my memory and think exactly what we are looking for here. So we are trying to find the conditions on A, B, C, and D. So condition doesn't mean that we need to find exact values, but condition means a relationship between A, B, C, and D, so that the tangent will be positive. Also, we want the derivative then to be positive. So we'll write that down. So for the derivative to be positive, we want either both numerator and denominator to be positive, or both numerator and denominator be negative. Now, we know that whenever we square a term or an expression or a number, we get a positive number. So we already know that the denominator is positive. So that means that we're going to need the numerator to be positive for the derivative to end up being a positive number. So we'll say that we want AB minus BC to have a positive value. So in other words, we're going to need AB to be bigger than BC. And this would be the conditions, in this case, for this derivative to be positive. That would be the relationship between AB and BC. And it seems that the coefficient D doesn't really play a great role in this case. So the relationship between A, B, and C would be AB bigger than BC. And obviously, we want the value of x to be different than negative D over C. So I hope this made sense again, and thank you for learning with me. Bye for now.